On this opening slide we are setting the scene for Chapter 2, Logistics and Information Technology. In the previous chapter we treated logistics mainly as flows of products and services. In this chapter we add a second layer, the flow of information that makes modern logistics possible. You can think of logistics today as two intertwined systems. One is the physical system of trucks, warehouses, containers, and inventory. The other is the information system of orders, barcodes, databases, and communication networks. Throughout this chapter, we will see that when the information side is designed and managed well, the physical side becomes faster, more reliable, and less costly. As we go through these slides, I would like you to keep asking, if I improve the quality, speed, or sharing of information in a logistics system, what changes in the physical operations will I see? That question will help you connect the technology concepts in this chapter back to the real logistics activities you already know. For example, when a retailer like the Joy De Dong plans its nationwide logistics, it needs not only warehouses and trucks but also detailed sales and inventory information from thousands of stores. Without that information layer, the physical network would be much less effective. In Vietnam, think about how Viettel Post or VN Post provide tracking codes for parcels. The ability for customers to see where their parcel is at any moment is a good illustration of how information adds value on top of the physical transport network. Follow-up question. If you had to design a basic information dashboard for a Vietnamese 3P to leaders provider, what 3 pieces of information would you show first to help them run their logistics network each day? This slide lists the 4 main topic areas for our chapter. The first topic is the benefits of using information effectively and efficiently in logistics management. We will look at why better information can reduce uncertainty, cut costs, and improve customer service across the supply chain. The second topic is the different types of information systems and how they are applied in logistics. You will see a family of systems: office automation tools, communication systems, transaction processing systems, management and executive information systems, decision support systems, and enterprise systems, and we will discuss who uses each one and for what kinds of decisions. The last 2 topics focus on the Internet's influence on logistics and the challenges that come with information technology. We will connect logistics to online retailing, cloud computing, and electronic procurement, and then step back and discuss issues such as security, implementation difficulties, and the limits of IT. As you listen, try to link each topic area to a concrete example from your own experience as a consumer or as an employee. A concrete example. After learning this chapter, you should be able to look at a company like Vinamilk or Mawson and identify which information systems they might be using to plan production, manage inventory, and coordinate distribution to thousands of points of sale across Vietnam. Another example is an e-commerce platform like Shopee or Tiki. Their ability to promise fast delivery across the country depends heavily on the information flows and systems we will discuss in this chapter. Follow-up question. Pick one company you know in Vietnam. Which objective on this slide do you think that company currently does well? And which objective is likely to be a weakness in its logistics information management? Here we look at the benefits of using information effectively and efficiently in logistics. The bullets on this slide highlight 4 key advantages. First, better information gives greater knowledge and visibility across the supply chain. When companies can see inventory levels, shipment status, and demand patterns across suppliers, manufacturers, and customers, they can coordinate activities much more smoothly. Second, there is greater awareness of customer demand via point-of-sale data and similar sources. Instead of guessing what customers want, firms can observe actual purchases almost in real time and adjust production, inventory, and transport plans accordingly. Third, better information supports improved coordination among manufacturing, marketing, and distribution. For example, if marketing plans a promotion, manufacturing and logistics can see the plan in advance and prepare capacity and stock to match. Finally, streamlined order processing and reduced lead times are major benefits. Electronic order entry, automated checking, and integrated systems allow orders to move quickly from customers to warehouses and transport providers. A question to think about is, Can you recall a situation where poor information, late, inaccurate, or incomplete, destroyed these benefits and caused visible problems in service or cost? In Vietnam, supermarket chains such as Company Opmart or Winmart rely on daily sales information from each store to adjust replenishment plans. When information is good, they can reduce out of stocks on popular items before weekends or holidays and avoid overstocking slow movers. Internationally, companies like Zara use fast and accurate information from stores to design and replenish fashion collections very quickly, which allows them to operate with lower inventory levels while still meeting demand. Follow-up question. Think about a time you saw empty shelves or excess unsold stock in a store in Vietnam. How likely is it that poor or delayed information about demand contributed to that situation? Slide 4 introduces the general types of information management systems we will discuss. Rather than one single logistics system, organizations rely on a set of systems that perform different roles, from simple office tools to complex decision support applications and enterprise-wide platforms. The picture on this slide, if you look closely, groups these systems into categories such as office automation, communication systems, transaction processing systems, management and executive information systems, decision support systems, and enterprise systems. Each category has a different purpose. Some support routine transactions, some summarize information for managers, and others help analyze complex decisions or integrate data across functions. As we move through the next slides, we will unpack each category, relate it to concrete logistics activities, and show how they link together. Try to keep this overview in mind so you can see where each specific system fits into the bigger picture of information management in logistics. In Vietnam, an e-commerce player like Lazada can differentiate itself by providing reliable delivery time estimates and real-time tracking, even if it uses the same carriers as competitors. That information transparency can become a key competitive advantage in customers' eyes. Globally, Amazon is a classic example of a company that competes heavily on information, order tracking, recommendations, and predictive shipping. All rely on sophisticated information systems that support logistics performance. Follow-up question. If two logistics providers in Vietnam offer similar prices and transit times, what types of information services could one of them offer to stand out and win more customers? On this slide we focus on office automation systems. These are the everyday software tools, word processing, spreadsheets, presentation software, and database applications that many of you already use. They provide effective ways to process personal and organizational data, perform calculations, and create documents and reports. For logisticians, the spreadsheet is especially important. Early spreadsheets were fairly simple, but modern spreadsheets can handle large datasets and support complex calculations. With the right add-ins, they can even solve basic logistics optimization models, such as choosing low-cost transport combinations or locating facilities using center of gravity methods. This means that even without specialized software, logistics managers can build useful models to support decisions. When you think about office automation systems, consider how many logistics tasks are already done with these tools: creating shipping reports, analyzing inventory levels, preparing route summaries, or presenting performance results. The question to reflect on is, are you using these tools only for basic tasks? Or are there opportunities to exploit their capabilities more fully for logistics analysis and planning? A practical example from Vietnam. A logistics manager at a company like Bok Hoa Sun may have raw data on thousands of SKUs and daily sales. Turning that data into information might involve generating category by store sales heat maps, identifying top-selling items, and spotting stores with unusual patterns. Internationally, a company like DHL can transform millions of shipment scans into information about lane performance, peak times, and bottlenecks that guide investment decisions in hubs and vehicles. Follow-up question. In your own context, can you describe a specific report or visualization that would turn raw logistics data into powerful information for planning or problem-solving? Now we turn to communication systems, another category of information management systems. The role of a communication system is to help stakeholders work together by interacting and sharing information in different forms: text, images, voice, and data, over distance and time. Examples of telecommunication technologies that support logistics include fax machines, personal computers, email, cellular phones, tablets, and smartphones. These tools allow salespeople to send orders quickly, drivers to receive updated delivery instructions, and warehouse staff to report real-time status. For instance, a driver might receive a revised route on a smartphone based on traffic conditions, or a warehouse worker might use a tablet to confirm a pallet has been put away. The key point is that communication technologies shorten the time between when something happens in the physical system and when people in other parts of the organization know about it. Ask yourself, in a logistics setting you are familiar with, which communication tools are most critical? What would happen to coordination and customer service if those tools suddenly disappeared for a day? In a Vietnamese context, simple tools like Zalo or internal chat systems are widely used by logistics teams to coordinate delivery issues, confirm last-minute changes, or share photos of damaged goods. These everyday communication tools can dramatically speed up problem resolution compared with older methods like fax or paper memos. Internationally, many logistics firms use integrated communication platforms that combine email, instant messaging, and document sharing so that headquarters and remote warehouses or drivers can coordinate in real time. Follow-up question: if your logistics team in Vietnam could only keep 2 communication tools, for example, email, phone, Zalo, internal portal, which would you choose and why? This slide continues with communication systems but focuses on particular logistics information technologies. One important example is electronic data interchange, or EDI. For many years, EDI was considered the measuring stick for business communication. It allowed companies to exchange standard electronic documents, such as purchase orders and invoices, directly between computers without paper or manual re-entry. More recently, wireless communication has taken a similar central role. With wireless networks and devices, information can be captured and transmitted from trucks, warehouses, ports, and even products themselves. Device examples include global positioning systems, GPS, which allow real-time tracking of vehicles, and tablets such as the iPad, which can be used by warehouse staff or drivers to receive instructions, record activities, and capture signatures. Together, EDI and wireless technologies illustrate how communication systems have evolved, from fixed batch exchanges of data to more flexible, real-time interaction. A good discussion question is, where would you still use EDI-style structured messages? And where do you need the flexibility of wireless internet-based communication in logistics today? For example, many large retailers and manufacturers in Vietnam exchange purchase orders and invoices with partners via EDI, especially when working with multinational suppliers or customers. This reduces manual entry and speeds up order cycles. On the wireless side, GPS-equipped trucks operated by companies like Viettel Post or GHN allow dispatchers in Hanoi or Ho Chi Minh City to see where vehicles are on national highways in real time and adjust routes if there are traffic jams or accidents. Follow-up question: if a Vietnamese company still relies mainly on phone calls and paper for order confirmation, what would be the first step you recommend toward adopting EDI or wireless-based communication to improve logistics performance? We now shift to transaction processing systems, or TPS. A TPS collects and stores information about transactions such as orders, shipments, receipts, and payments. Its primary objective is efficient, reliable processing of large volumes of routine transactions. Organizations can choose between real-time processing and batch processing. Real-time processing updates records immediately. For example, inventory is reduced as soon as an order is scanned at the checkout. Batch processing collects transactions and updates records at set intervals, such as once per night. Both approaches are used in logistics, depending on the urgency and volume of the data. Examples of technologies that feed data into TPS include EDI messages and automatic identification technologies. In point-of-sale (POS) systems, Barcode scans or similar inputs automatically create transaction records without manual typing. When you think about TPS, imagine the number of individual steps involved when you buy an item in a store or place an order online. Every one of those steps is recorded and handled by a TPS somewhere in the background. Consider a supermarket in Vietnam. Every time a cashier scans a product at the POS, a transaction is created. In a real-time TPS, inventory is updated immediately and the system can flag items that need replenishment. In a batch TPS, these updates might only occur at the end of the day, which delays the response. Internationally, companies like Walmart rely on real-time TPS to monitor sales and inventory in thousands of stores, allowing them to coordinate replenishments with suppliers almost continuously. Follow-up question: in your opinion, for which logistics processes in Vietnam is real-time processing essential? And for which processes is overnight batch processing still acceptable? Slide 9 continues the theme of transaction processing systems. While the title is the same, this slide usually accompanies a diagram that shows how TPS sits at the base of the information system structure and feeds data to other systems like MIS, DSS, and enterprise systems. The crucial idea is that TPS provides the raw data foundation. If orders, inventory movements, and shipment events are captured incorrectly at the transaction level, any reports, analyses, or decisions built on this data will also be flawed. In logistics, where thousands or millions of transactions occur each day, small error rates can create serious problems in inventory accuracy, billing, and performance measurement. So, as we move into higher-level systems on later slides, keep in mind that their value depends heavily on the quality of the underlying transaction processing. A useful question for reflection is: what controls and checks does your organization use to make sure transaction data are accurate, complete, and captured at the right time? A typical Vietnamese example is a 3PL that handles thousands of parcel deliveries per day. If drivers or warehouse staff forget to scan parcels at key points, TPS data will be incomplete, leading to tracking errors and customer complaints about lost shipments that are actually still in the system. On the other hand, when every scan is captured correctly, managers can identify which hubs are slow, which routes have delays, and which customers have special handling patterns, all based on solid transaction data. Follow-up question: what simple control or training program could you put in place to improve the accuracy of transaction capture, for example, scanning discipline, in a logistics operation you know? On this slide we focus on automatic identification technologies that are closely linked to transaction processing systems. These technologies capture data about products or transactions with minimal human intervention and then feed those data into information systems. Examples include optical character recognition, which can read printed characters; machine vision, which uses cameras and image processing; voice data entry, where workers speak codes or quantities into a system; magnetic strips on cards, barcode scanners; and radio frequency identification, or RFID. Each technology has its own strengths in terms of speed, accuracy, cost, and suitability for different environments. In a logistics setting, automatic identification is what allows a pallet to be scanned instantly at a warehouse gate, a parcel to be sorted automatically, or a container to be identified without manual checking. The question to consider is: when you compare manual data entry to these automatic identification methods, where do you see the biggest gains in accuracy and speed, and what new risks or costs might be introduced? In many small Vietnamese warehouses, workers might still record receipts and issues on paper, then later key them into a computer. Switching to barcode labels and handheld scanners would allow immediate, more accurate capture of movements and reduce double work. Globally, companies like UPS use highly automated sorting centers where parcels move on conveyors and are scanned by fixed scanners and cameras, directing each parcel to the correct chute with minimal human intervention. Follow-up question: if you had to introduce one automatic identification technology into a medium-sized warehouse in Vietnam, which would you choose first, barcode, RFID, or voice entry, and why? This slide looks more closely at RFID, one of the most important automatic identification technologies. An RFID system consists of three main parts: a scanning antenna, an RFID tag or chip that stores data, and a receiver that interprets the data sent by the tag. Compared with a traditional barcode, RFID offers several advantages. It does not require a clear line of sight between the tag and the reader, so tags can be embedded in packaging or attached where they are not easily visible. RFID tags can store much larger amounts of data than a typical barcode, such as serial numbers, batch information, or handling instructions. In many systems, tags also have read-write capabilities, meaning data can be updated as the item moves through the supply chain. Imagine a pallet moving from factory to port, then to a distribution center and finally to a store. With RFID, each handling point could automatically update the tag and the central system, giving continuous visibility without repeated manual scanning. A question to think about is, in what types of logistics operations do these advantages justify the higher cost of RFID compared with traditional barcodes? You can imagine RFID use cases in Vietnam in sectors like garments or footwear, where large exporters ship many cartons of similar products. RFID tags can allow quick counting of cartons going into export containers without opening and checking each one manually. Internationally, retailers like Decathlon or Uniqlo have used RFID to speed up inventory counts and reduce out-of-stocks in stores by having near real-time visibility of items on the sales floor. Follow-up question: for a Vietnamese company that sells high-value items, such as electronics or branded fashion, what would be the most convincing argument to invest in RFID instead of relying only on barcodes? We now move up the hierarchy to Management Information Systems, MIS, and Executive Information Systems, ICE. These systems take the detailed data generated by transaction processing systems and convert them into information that managers and executives can use to monitor performance and manage the organization. MIS typically produce regular, structured reports, such as weekly inventory summaries, monthly freight cost reports, or quarterly service level statistics, that help middle managers keep operations on track. ICE, by contrast, provides senior executives with highly summarized, often graphical views of key performance indicators. Both systems aim to provide the information that decision makers really need, without overwhelming them with raw data. In logistics, these systems together form a logistics information system. The people, equipment, and procedures used to gather, sort, and analyze data and then disseminate relevant, timely, and accurate information to logistics decision makers. As you think about MIS and ICE, ask yourself, what reports or dashboards would you consider essential for managing logistics in your own organization or in a company you know well? Think about a Vietnamese distributor of fast-moving consumer goods. Its TPS records each delivery to small grocery stores, while an MIS might generate weekly reports summarizing sales by region, product category, and sales representative. Managers can use these reports to spot regions with declining sales or products that are overstocked. Internationally, a company like Maersk can use MIS to summarize port-to-port container flows and equipment utilization by region, based on millions of TPS records, to support network planning and pricing decisions. Follow-up question: if you were the logistics manager of a regional distributor in Vietnam, which 3 MIS reports would you request every month to keep control of warehousing and transportation performance? Slide 13 keeps the focus on MIS and ICE and often accompanies a figure showing how information flows from transaction processing systems up to management and executive systems. The key point is that MIS and ICE do not create data on their own, they depend on accurate, consistent input from lower-level systems. For logistics managers, MIS might provide detailed reports on warehouse productivity, carrier performance, or inventory turns by product line. ICE might present a dashboard with overall logistics costs as a percentage of sales, on-time delivery percentages, or average order cycle times. Both levels are important. Managers need detail to diagnose problems, while executives need summaries to set strategy. A useful question here is If you had to design one MIS report and one ICE dashboard element for logistics, what would you include in each? And why? How would you ensure that both are drawing on the same underlying data so that the organization has one version of the truth? For a Vietnamese retailer with both physical stores and an online channel, MIS might show detailed performance of each distribution center, while ICE provides the board of directors with a simple view of total logistics cost as a percentage of sales and overall service levels. Internationally, companies like Nestlé or Unilever use multi-layered reporting, operational dashboards for logistics supervisors, MIS summaries for country managers, and high-level ICE indicators for regional or global executives. Follow-up question: how would you explain to a senior executive in Vietnam why it is dangerous to manage logistics purely from ICE dashboards without occasionally examining the underlying MIS or TPS details? Now we introduce decision support systems, or DSS. Unlike MIS and ICE, which mainly report what has already happened, DSS are designed to help managers make more complex, less structured decisions by providing information, models, or analytical tools. In logistics, DSS can be used for vehicle routing issues, such as designing daily delivery routes that minimize distance or time, for inventory control decisions, such as setting safety stock levels under uncertain demand, for developing automatic order picking systems that balance productivity and accuracy, and for optimization models that support negotiations between buyers and sellers, such as choosing the best combination of carriers and lanes. You can think of DSS as a laboratory, where managers can test different scenarios and see the likely outcomes before making real-world changes. A question to consider is, can you recall a logistics decision that was made mainly by intuition? How might a simple DSS, perhaps even a spreadsheet model, have improved that decision by making trade-offs more explicit? In Vietnam, a beverage company might use a routing DSS to design daily delivery routes for trucks serving cafes and grocery stores in Ho Chi Minh City, taking into account traffic patterns and delivery time windows. This can significantly reduce total distance and fuel cost compared with manual planning. Internationally, parcel integrators like FedEx and UPS use sophisticated DSS for vehicle routing, network design, and capacity planning to ensure that service commitments like next-day delivery can be met reliably. Follow-up question: think of a logistics decision in Vietnam, such as planning Tet holiday deliveries. How could a DSS help you test different scenarios, for example, adding temporary vehicles or extra warehouse shifts, before you commit to a final plan? This slide goes deeper into specific decision support techniques. The first is simulation, a technique that models a real-world system using mathematical equations to represent the relationships among its components. In logistics, simulation might be used to model a warehouse layout, a distribution network, or a port, and then test what-if scenarios. What happens to waiting times if we add more docks? Or to costs if we change delivery frequencies? The second technique is application-specific software, developed to help managers deal with particular logistics processes or activities. These tools embed specialized models and algorithms, for example, for vehicle routing, dock scheduling, or slotting products in a warehouse. A popular way to access this kind of software today is on-demand or software as a service, often delivered through cloud computing, where companies pay to use the software over the internet rather than installing it on their own servers. The main message is that DSS techniques move us from simply reporting the past to actively exploring alternatives for the future. As you think about your own context, which logistics decision would you most like to simulate or analyze with specialized software before implementing changes in the real operation? A Vietnamese 3PTA leaders could use simulation to test the impact of adding a cross-dock facility in Da Nang on transit times between the north and the south. Without physically building it first, they could simulate different volumes, schedules, and cut-off times to see how performance changes. Internationally, port authorities in places like Singapore or Rotterdam use simulation models to analyze container yard layouts and vessel berthing strategies to minimize waiting times and congestion. Follow-up question: if you were simulating a new e-commerce fulfillment center for Vietnam, Which 3 performance measures would you track in the simulation to decide whether a proposed design is good or needs adjustment? Here we look at 2 important examples of logistics-related application-specific DSS: Transportation Management Systems, TMS, and Warehouse Management Systems, WMS. A TMS is a software package that automates and supports key transport activities. It can help build loads, select carriers, tender loads, track shipments, and audit and pay freight bills. By using a TMS, companies can consolidate shipments, reduce empty miles, improve routing, and gain better visibility into transport performance. Many firms report significant reductions in transportation costs and improvements in service reliability after implementing a TMS. A WMS, in contrast, focuses on the storage and flow of materials inside the company's facilities. It manages inventory locations, directs receiving and put away, controls picking and replenishment, and may support value-added services like labeling or kitting. A WMS can increase inventory accuracy, improve picking productivity, and provide real-time visibility into stock. A question to reflect on is, if your organization could implement only one of these systems first, TMS or WMS, which would likely produce the greatest benefit? And why? In Vietnam, many logistics companies are adopting TMS to manage contract trucking and parcel deliveries more efficiently. A TMS can help a firm like GHN consolidate volumes from multiple online sellers, select appropriate carriers for long-haul moves, and track delivery performance across provinces. A WMS might be used by a company like Vinamilk or True Milk to manage large cold storage warehouses, ensuring that products with different expiry dates are stored and picked correctly and that inventory records match physical stock. Follow-up question. Imagine you are advising a growing Vietnamese e-commerce startup. Their pain point is many delivery failures and poor visibility. Would you recommend they invest first in a TMS, a WMS, or something else, and why? Slide 17 continues with decision support systems and often serves as a summary of the DSS category. The essential idea is that DSS assist rather than replace human decision makers. They provide models, data, and analytical tools, but managers still need to interpret the results and consider qualitative factors such as relationships, risks, and strategic priorities. In logistics, DSS can operate at different levels. At the strategic level, they might support decisions about where to locate warehouses or how many facilities to operate. At the tactical level, they can help set inventory policies or design route structures. At the operational level, DSS may assist with daily vehicle dispatching, staff scheduling, or order picking priorities. As we add more data and more sophisticated analytics, DSS become more powerful, but they also require users who understand both the logistics context and the limitations of the models. A good question is, what skills do logistics managers need to use DSS effectively? Beyond just knowing how to operate the software. For example, a Vietnamese retailer planning whether to open a new regional warehouse in central Vietnam could use a DSS to compare scenarios, keeping only warehouses in Hanoi and Ho Chi Minh City versus adding a third facility near Da Nang. The DSS would estimate transport costs, inventory levels, and service times for each option. Internationally, companies like Coca-Cola frequently use DSS to decide where to locate bottling plants and distribution centers in new markets, balancing cost efficiencies against service requirements. Follow-up question. Beyond technical skills, what soft skills do you think a logistics manager in Vietnam needs to interpret DSS outputs and explain recommended decisions to non-technical colleagues or top management? On this slide we introduce data mining as a decision support technique. Data mining is the application of mathematical tools to large bodies of data in order to extract correlations and rules, that is, patterns that are not immediately obvious from simple tabulations or reports. For logistics, data mining can reveal valuable insights. For example, analysis of sales and weather data may show that demand for certain products increases sharply when a storm is forecast, allowing companies to position inventory in advance. Data mining can also help identify customer segments with different service needs, detect combinations of products that are often purchased together, or spot early warning signs of stockouts. Effective data mining depends on data warehouses, which are central repositories that bring together relevant data from across the organization. Instead of leaving data scattered in separate operational systems, a data warehouse allows integrated analysis, providing a more complete picture for decision-making. Think about your own organization or a company you know. If you could mine its logistics data, what type of pattern or rule would be most useful to discover? In Vietnam, a retailer like FPT Shop might use data mining on historical sales data to identify which laptop models sell best in which cities and during which months, helping them plan inventory and promotions more accurately across their nationwide store network. Internationally, companies like Amazon mine customer purchase histories to forecast demand for new products and to recommend complementary items, which in turn influences how they plan inventory and storage in their fulfillment centers. Follow-up question: if you had access to 3 years of detailed logistics data for a Vietnamese company, what specific pattern would you most like to discover through data mining that could lead to a clear improvement in cost or service? This slide turns to enterprise systems, which create and maintain consistent data processing methods and an integrated database across multiple business functions. Rather than having separate, disconnected systems for logistics, marketing, production, and finance, an enterprise system links them together so that information flows more smoothly across the organization. A common example is enterprise resource planning, or ERP. An ERP system allows a company to automate and integrate the majority of its business processes and to produce and access information in a real-time environment. For logistics, this means that information about orders, inventory, production schedules, and financial transactions is coordinated, reducing inconsistencies and delays. At the same time, ERP systems have shortcomings. They can be very expensive to install. The implementation process is often long and complex, and early versions did not always include strong logistics-specific capabilities like advanced TMS or WMS modules. Organizations therefore need to weigh the benefits of integration against the costs and challenges of implementation. A good question is, how might a logistics manager make the case either for or against a major ERP investment? A Vietnamese manufacturing company that implements an ERP system, such as SAP or Oracle, can link its production planning, purchasing, inventory, and distribution modules. This allows sales data from Hanoi to influence production schedules in Binh Duong and inventory positioning in Da Nang in a consistent way. Internationally, companies like Siemens or Procter & Gamble use large ERP installations to coordinate operations across dozens of countries, ensuring that logistics decisions are aligned with finance, marketing, and production plans. Follow-up question: if a Vietnamese firm currently uses many small, disconnected systems for logistics, accounting, and sales, what criteria should it consider before deciding to invest in a large ERP project? We now